So who hasn't played tic-tac-toe in their childhood? I will play it today. So today we'll play tic-tac-toe. It will not actually play the game, we'll create one game. So this is a Leetcode premium medium problem. We'll implement one tic-tac-toe game class and see how it goes. So assume the following rules are for the tic-tac-toe game. On an n cross n board between two players. So a move is guaranteed to be valid and is placed on an empty block. Once a winning condition is reached, no moves are further are allowed. A player who succeeds in placing n of their marks in horizontal, vertical or diagonal row wins the game. So we have to implement the tic-tac-toe game tic-tac-toe class. So it will take one parameter, that is n. So the board size will be n cross n, and one move function that we have to write. So that will take one row, one column, and the player. So when player is making a move at that row column cell. So after this move, the move is guaranteed to be valid, and the two players alternate in making moves. So we have to, at each move, we have to return 3 values. If there is no winner after this current move, we have to return 0. If the player 1 wins after this move, then we'll return 1. Otherwise, if player 2 wins, we'll return 2. So let's see a few examples. So here we have only one example. This is a tic-tac-toe game, and with this 3 size means there will be 3 cross 3 board. And at each move, you see player 1 is making move at 0 0. So this is the board, and see player 1 is making a move at 0 0. So we can place X or O, right? Or you can cross or 0. So then next turn player 2 makes a move at 0 2 and so on. So at the end we see here player 1 makes a move at 2 1 sail. So here you see in this sail, and you see in this row we have 3 cross. That means player 1 wins and will return 1 after this move, and here the match ends. So consider first we'll take one board that will be n cross n size. So this is the brute force approach I am discussing now, and for each player will mark the ith row and jth column with its player value like 1 or 2. Now after making one move, we have to validate the row, validate the column, validate the positive diagonal, validate the negative diagonal to check if any of this row, column or diagonals satisfy this. I mean in each of this row, in any of this row, column or diagonals, if we have n number of players. How do you check the positive and negative diagonal? So this is the positive diagonal, right? So here you see what are the positive diagonal row column values. So this is 2 0, this is 1 1, and this is 0 2. You can take the values in any order, but if for any of the cases you see row plus column is 2. That means row plus column is n minus 1. N is 3 here because we have a 3 cross 3 board. What is the negative diagonal cell values, right? So this is the negative diagonal values 0 0, 1 1, 2 2. That means row equals to column for negative diagonal. Now what is the time complexity for the move function here? So whenever I am making a move at any cell here, I have to check the row, I have to check the column, I have to check the diagonal, I have to check the positive, negative, both diagonal. In each of the cases, we have to check n number of cell, right? So order of n for each move. So let's see the code first, then we'll see how to improve this complexity. Alright, first we need to keep track of this n variable as well for our simplicity. Now we need the board. Board will be of size n cross n, right? So let's take 0 star n for n range n. Next I have to write the move function. Move function is basically in this board for this row and column, and for this cell I'll mark this player. So after making this move, we have to check in this current row, current column and the diagonal, positive and negative diagonal, whether this player has won or not. So for that, let's say I will write few helper function. First one is to validate the row, that will take the row and the player. Next we will have a function that will validate the column, that will take the column and the player. Next we'll have the function that will validate diagonal, that won't take any row or column because there is only one diagonal and positive and negative diagonal. And next we need a similar method for validating negative diagonal. Now let's write this helper functions. How we'll check if a row is satisfied for I in, for let's say for column in range self dot n, if self dot code row column not equals to player, then I will return false. Otherwise, if we are coming out of this for loop, I will return true. Next, we'll do the same thing, but for each row and this column, right? Next, we'll check the diagonal. So let's say the row and column will start, this is a positive diagonal, row will start at 0 and column will start at self dot n minus 1. Now while row less than self dot n, we'll just check the same thing. And then we have to update row, right? Row column is, row will be incremented and column will be decremented. Similar thing we'll do for, okay, after this while loop, if while loop is over, then that means we can return true. This positive diagonal is satisfied. The player has marked all the cells in the positive diagonal. For the negative diagonal, both row and column will start at 0, and the same but in this case both row and column I have to update, like increment by 1. So that's it. In the move function, after making the move, I'll just verify row, column and diagonals. Self dot validate row with the player, or self dot validate column with column and player, or self dot validate diagonal with the player, or self dot validate negative diagonal with the player. We can return true if any of this is satisfied. No, we will not return true because this player has won, right? So we'll return the player. Otherwise, no one has won, so we'll return 0. So that's it. That's the code. So let's run this. This works. Okay, this works, but let's see how to improve this. Now, in the previous solution, we saw the for move function had time complexity order of n. We're trying to improve this. Now, let's first check the diagonals. Let's say I'm making a move at this position, right? Do I need to check the diagonals? Because this row and cell, row or column, it doesn't come in any diagonal values, right? So it's unnecessary to check this diagonal for this row, this move. So we have to check diagonals only when row plus column equals to n minus 1, that is for positive diagonal, and row equals to column, that is for negative diagonal. So here we have a better approach. So earlier we are just having a board and then we are making the mark in this board and then we are going through the rows and column and diagonals to check the number of cells covered by this player. But instead of that, if we can just keep track of the rows list and one columns list, right? We want to know for this row, when I'm making a move at this row, you want to know in this row how many cells are marked by this player. That's what we want to know, right? So instead of having this board, if we can just take one variable for this row, that's enough, right? So if we have n number of rows, we need a list of n numbers, right? So that's what I'm taking. For player 1, I am taking a rows list that is of size n. For player columns, player 1, I am taking a columns list that is of size n. Similarly, for player 2 also I am taking a list of size n for both rows and columns. So at each move, we will just check for this row. Like here you see if the player is marking here at this 2, 1 cell. So this is at row 2, right? We'll just go to player 1 rows of 2. We'll see the number of rows marked by this player, and if it is n, then we can return this player as 1 in this move. Now here I am just trying to write a simple pseudocode. So yeah, player 1 rows is a list of size n, columns also is a size of n, and here player 1 is making a move at row 2, column 1. So player 1 rows of 2 will be incremented by 1. Player 1 of columns of 1 will be incremented by 1. Then I will check the value at player 1 of rows of 2. Means at the row 2, how many, what is the value of player 1 of rows 2? That will give the number of cells marked at this row 2. So if player 1 of row equals to n, that means we can return that player because that player has marked all the rows, all the values in that particular row. Similarly, player 1 of columns of this column, for this particular column, if the value is n, that means the current player has marked all the cells in that column. Similarly, for the player 2, we'll keep a different list and we'll just check for using this rule. Now, do you need to keep track of two different lists, one for player 1, one for player 2? I don't think so, because if we had multiple players, so that would have been our strategy. But so what we can do is we can take for player 1, we can take the player number 1. For player 2, we can take player number is -1. So we'll just take one rows list, one columns list. And if player is 1, we'll just increment the value. If player is 2, we'll just decrement the value. So, and for positive diagonal and negative diagonal, I am just taking one variable that is initialized to 0. So what happens if player 1 first marks one diagonal value, will increment it 1. Then player 2 marks a value at the same diagonal, that will be decremented to 1. That will be decremented to 0 again, right? But if it happens that one of this player marks all the positive diagonal value, then this positive diagonal value will be either n or -n, right? So what will be our strategy here? If absolute value of rows of row equals to n, or absolute value of columns of column equals to n, or absolute value of positive diagonal equals to n, or absolute value of negative diagonal equals to n, then we can return that this player at this current move has won. So what will be the time complexity for this solution? It's basically after each move we are making only constant operations. We are just incrementing the particular row value, the column value, and this positive and diagonal, negative diagonal value. Then these are all constant operation. I am just checking the absolute value of this 4. So time complexity of move function will be order of 1. Okay, first we need to keep track of the n variable as it is, and next we don't need the board, we need rows. That will be a list of size n, and then we need to keep track of the columns. That will also be, there are n columns, right? And that's it. And then we need to keep track of the positive and negative diagonal. Both are initialized with value 0. That's it. Now what we'll do is, for each move I have to update the rows column, self dot rows of row plus equals to player, but we have to update the player first. Player is player if player equals to 1 else -1. Similarly, I will update the column, and when we'll update the diagonal, if it is positive or negative diagonal path. When it is in positive diagonal path, if row plus column equals to self dot n -1, then we'll do self dot positive diagonals plus equals to player. Similarly, we'll update the negative diagonal when row equals to column, right? Then we'll update the negative diagonals. And at each of this operation, after each of this update, we have to check whether this row is satisfied or not, column is satisfied or not, or any diagonal is satisfied or not. How do we do that? We will check the absolute value of this row. It should be self dot n, right? And return true. Not true, I have to return player, right? So player, but if player equals to 1 else 2. Similarly, we have to do it for columns. And then we have to do it for positive and negative diagonal as well. It will be self dot positive diagonals, and similar thing for negative diagonals. Okay, done. And now if none of this returns anything, then we have to return 0, because no one has won at this move, at this moment after this move. So this is the code. Let's run this. What happened here? Positive diagonals. What's wrong? Okay. Yes. This works. Let's submit it. Yeah, it is much more efficient. What's the complexity? It's order of 1.